If you've ever looked at a sad, wilting plant and just thought to yourself, ugh, I have a black thumb, then this is for you. We're going to get into why your potted plants are struggling. And I promise you, it's probably not your fault. It's just physics.
All right, let's start with the classic mystery every plant parent faces. You look at your plant, it's drooping. Is it thirsty? Or have you, loved it a little too much with the watering can? It is one of the most frustrating things to figure out.
And what makes it so maddening is that the symptoms look almost exactly the same. A thirsty plant wilts. But guess what? A drowning plant also wilts because its roots are rotting and they can't take up any water. The leaves turn yellow in both cases. So how are you supposed to know what's really going on?
Well, the real reason is that we've been thinking about this problem all wrong. This gets especially confusing for our indoor plants because most advice out there just assumes your pot behaves like a little patch of garden, which it absolutely does not.
See, a plant pot isn't just a tiny piece of the earth. Out in a garden, extra water can just drain away, deep down into the soil. But a pot, that's a closed system. It has a bottom. And that one simple fact changes absolutely everything about how water behaves inside it. So let's break this down. Healthy soil, or what we call a container medium, is really a mix of three things. The solid bits, like soil and amendments, water, which clings to those solid bits, and air, which fills the tiny spaces in between. And that last one, the air, is the secret hero of this whole story.
That's right, roots have to breathe. They need oxygen to do their job, to absorb water and nutrients. When all those little air pockets in the soil get totally filled with water and stay that way for too long, the roots can't get any oxygen. They literally start to drown.
So how does a pot end up trapping so much water and pushing out all that precious air? The best way to wrap your head around this is with a really simple analogy: a kitchen sponge. Just think about it for a second. If you soak a sponge and then hold it up in the air, a bunch of water drips out, right? But it never gets completely dry just from gravity. The sponge stays damp because the water surface tension inside all those little pores is strong enough to hang on, fighting against gravity's pull.
Well, in the world of plants, that zone of completely waterlogged soil that sits at the bottom of a pot actually has a name. It's called the perched water table. It's perched because it's just sitting there at the bottom, totally saturated and unable to drain any further, just like the water in our sponge.
Now here's the really critical part. The height of that soggy, perched water table, it pretty much stays the same no matter how tall the pot is. So if you have a shallow pot, that swampy, airless zone takes up a huge percentage of the total soil volume, leaving very little room for the roots to actually breathe.
And right about now, you're probably thinking about that classic piece of advice we've all heard. Oh, just put a layer of rocks or gravel at the bottom for better drainage. It sounds like it makes perfect sense, doesn't it?
Well, prepare to be shocked. Adding gravel does not get rid of the perched water table. It can't, because the water has a tough time moving from the fine particles of the soil into the big air gaps of the gravel. The water table just forms on top of the gravel layer instead.
What that means is, adding gravel actually makes the problem worse. All you've done is made the soil section of your pot shallower. You've lifted that swampy, oxygen-deprived zone higher up, putting your plant's roots in even more danger of drowning. Okay, so if gravel is officially a bad idea, what actually works? How do we get that perched water table lower and give our plant's roots the air they desperately need?
The answer is actually pretty simple. Just use a taller pot. A taller column of soil has more weight, and that extra gravitational pull is what helps to pull more water out of those little pores, which lowers the perched water table and gives you a much larger volume of nice, airy soil.
And this visual really says it all. The width of the pot doesn't change anything about that saturated zone at the bottom. The only thing that changes the ratio of soggy soil to airy soil is the vertical height. When it comes to drainage in a container, taller is always better.
So let's bring this all back together. As one scientific paper put it, having a plant fail isn't a sign that you have a black thumb, it's really just a symptom of an unmanaged system. You are basically fighting against laws of physics you didn't even know were in play. So, once you stop blaming yourself and instead start focusing on designing the right physical environment for the roots, one with plenty of oxygen, healthy growth stops being a matter of luck. It becomes the inevitable result.
Now, this whole idea of creating airspace also applies to the ingredients you pick for your potting mix. So if you want the practical breakdown of how things like perlite or bark or peat moss affect that all-important airspace, our blog article walks through all of the details.